Hello, and welcome to Fiction Nonfiction podcast from Literary Hub, where we believe that every issue in your social media feed or in the evening news has already been tackled somewhere in literature. I'm Jennifer Maritza McCauley, author of Neon Steel.
And I'm Whitney Terrell, author of the novel The Good Lieutenant.
Whitney, would you consider yourself a risk taker?
Do I look like a risk taker? I'm sitting here at a desk doing a podcast. All I do is sit here at this desk, either do this or type on a computer. I don't know, it's not very risky.
Okay, but what about the war reporting? What about deciding to be a writer in the first place?
The war reporting was risky, and I'm glad that that part of my life is over. And there have been other risks that I've taken in the past. I will admit that. But if writing counts as being a risk taker, then you're one too.
I don't know about embedding myself with deployed troops at war risky, but maybe like going on a few miles over the speed limit, sometimes risky, but regarding your wild side.
I don't know. That's going a little far.
Oh, I want to know more, but okay. New studies are revealing that people may actually have a genetic predisposition for choosing danger or situations that can lead to it.
Okay. Well, this supposed wild side of mine that you've invented, if I'm predisposed to it, is it even a choice?
Excellent question. And our guest this week is all about exploring that answer. She's a psychologist and behavioral geneticist who works with cutting edge research from the lab she runs at the University of Texas at Austin. She's been honored by the American Psychological Association for her distinguished scientific contributions to the study of genetics and human individual differences. And she just released her second book, Original Sin on the Genetics of Vice, the Problem of Blame, and the Future of Forgiveness, which explores the very tangled interplay of genetics, culture, and agency in shaping human behavior. Dr. Kathryn Paige Harden, thank you so much for being on the show with us today.
Thank y'all so much for inviting me.
We're
Absolutely.
glad that you can be here with us. You run as we just said, you run the developmental behavior genetics lab at the University of Texas. Not something that I would immediately know what it did if you were to tell me about it. And you say, as a psychologist, you study how people's genes combine with their environment to affect their thoughts. At another point, you say, we are studying the genetics of sin. Always interesting to writers. So how do you do that?
Yeah. So let's start with the genetics part because that's a little bit more straightforward. We study genetics of human behavior in a couple different ways. One of the ways is by measuring people's DNA. So we're taking, people give a blood sample or they spit into a tube and it goes to a lab and that reads their DNA sequence. And 99% of our DNA is the same across all people, regardless of race, regardless of ancestry. But we're really interested in that 1% that differs between people. So we're looking for specific spots in the genome, specific spots in the entirety of your DNA sequence where people differ in a single DNA letter. So I might have a T in that spot and you might have a G in that spot. And then we are doing this in hundreds of thousands or millions of people and looking at, are there genetic differences that are more common in people who show some kind of behavior? So this is a really common approach across medicine, across psychiatry, across psychology. You might be looking at what genes are more common in people who are tall, or what genes are more common in people who have heart disease early. What makes our research a little different is that we're looking at genes that are more common in people who show certain forms of behavior. And I write in the book about it, it could be called sinful behavior, but sin is not a scientific term. There's no, psychology of sin. Sin is a moral
What?
judgment or a religious judgment.
My father did not feel that way.
Good mind.
How I would say it scientifically is we're interested in behavior that's disinhibited or impulsive, where people are doing things that might bring them pleasure, but might have negative consequences. And some of those negative consequences might be social judgment. So we can think about minor forms of impulsivity, like I like to have sex with lots of people, or I like to drink a lot. And then we can think of more serious, harmful forms of impulsivity, like I aggress against another person and I hurt them when I'm mad or I'm upset. So what we're interested in studying is can we find specific genes that are more common in people who persistently engage in these behaviors that violate social or moral or legal norms? And if we can, what do they do in the body, in the brain, and development? And then this is the question that my book is really interested in is, what do we do with that knowledge? How do we make sense of the fact that people are born differently likely to engage in behaviors that are then judged or punished or moralized in a society?
So, and we're going to talk about how those specific genes and what they might be and the kind of behaviors that they might encourage. But I have a question of like, how do you get millions and millions of things to study? Like, where's that coming from?
Yeah. So most of our data comes from two sources. And the first source is Northern European biobanks that are collected by their governments. So the UK has something called UK Biobank. Iceland has genotyped many of its citizens. The Netherlands, Sweden, Norway, they've genotyped many, many people. And that's important because we end up studying the genes of a really narrow slice of human global diversity. It's people who are racially identified as white, whose recent ancestors are all from Northern Europe. And then in the United States, it's a lot of 23andMe customers. So people who have paid a private company to genotype, and then that company has shared the data with the scientific community for research purposes.
Do people have a choice? This just came up in workshop. A student of mine wrote an essay about discovering through 23andMe that she had a brother that she and her father did not know about, right?
Oh my gosh.
And we were talking about like, well, can't you opt out? I mean, how many people opt in? How many people opt out? How is this genetic information and there's a difference between if you opt out for like letting regular people know, can they still sell it for scientific use? How does that all work?
So it depends on the company and it depends on their consent procedures. But usually what you're thinking about is people can consent to know things about themselves, consent to share that information with a pharmaceutical company, or maybe they only want it for non-commercial purposes, so for scientific discovery. But when you're giving informed consent, I think it's really important as a researcher or as a company to educate people about what the potential risks are. That knowledge can be risky in and of itself, because people don't necessarily know. They think, oh, I'm going to, learn what percent, British Irish I am versus what percent French German I am. And they're not thinking that there's a risk to discovery that they might find out that who they think their father is not their biological father, or they have DNA relatives. And increasingly, there's bioethicists working in this area, because if I give my DNA to a repository, that doesn't just give information about me, that gives information about all of my relatives too. If you are a person of European descent, you are identifiable from information that's been given to companies like 23andMe, because you're genetically related to people who've participated in those experiments or who have used those companies before. So I think that now people's awareness of the complexity and sensitivity of genetic data is increasing, but there's still a lot of responsibility for us as researchers to appropriately convey to people what are the risks of knowing something that you might not be prepared to know if you get information about your genetics.
One of the things that I thought was really interesting is that you outlined two definitions of sin. So one is an act that contravenes laws or customs, in other words, an act. The second is original sin, the title of your book, or hereditary sin. Can you talk about the second idea and how it applies to behavioral genetics? It's really interesting to me that many religious thinkers and philosophers wrestle with this exact concept before even knew what genes were.
Yeah. So original sin was a doctrine that was proposed by Augustine, Saint Augustine, who was eventually canonized by the Christian Church, who was active at the end of the 300s, early 400s. So a time in which Christianity had become the official religion of the Roman Empire. And also the empire was at a state of overreach, almost collapse, a really interesting time in Roman history. And he articulated it was an innovation in Christian thinking, this new understanding of the relationship between the body and sinfulness and what justifies divine punishment and what justifies suffering. So Augustine's idea was that Adam and Eve sinned in the garden. That was the first violation of God's rules. And that sinfulness changed them physically such that it was then inherited through the sex act in every subsequent generation. And this is now, a really commonplace idea in Christian thought, but again, was a radically new idea in Christian history at the time he proposed it. And it justified
prefigures the idea of genetic transmission, really.
It does. So we have these very ancient ideas of heredity, of things being inherited from parent to children. And we have these very ancient ideas that heredity could be more than just physical characteristics. It could be social rank, obviously, was very familiar to the ancients, but even the idea of deserving suffering or fallibility or damnability. We didn't have the word gene until the 20th century. We didn't have the word genetics, but we have much older ideas that predate any of our knowledge of the molecular mechanism of physical heredity. Much older stories about what's inherited from parent to child. So Augustine was proposing that sin wasn't just, I'm doing something that contravenes a standard. It was a condition that was attached to human nature that was physically inherited from generation to generation. And this innovation in Christian doctrine didn't go unopposed. And he had a primary intellectual rival at the time, a British monk named Pelagius, who really argued very vehemently against the idea of original sin. And Pelagius contended that for something to be sin, for something to be morally bad or blameworthy or evil or deserving of punishment, it had to be an act of will. And if it was physically inherited, if it was part of nature, then it couldn't be an act of will. So something could either be natural, biological, inherited, or it could be sinful. So what I find really interesting about this as a behavior geneticist is these are two stories about what is the relationship between what you inherit, what you do, how you behave, and what you are punishable for or blameworthy for that predate any of our scientific knowledge about this. And even though Augustine officially won the debate within the Christian church, I think we still see echoes of both of these stories in how we are making sense of our modern scientific knowledge. And again, we discovered the structure of DNA 72 years ago, 1953. It wasn't that long ago, 73 years ago. Whereas we've been debating the relationship between inheritance and morality for nearly 2 millennia. So I think we have these stories that have been circulating within Christian inflected history for a long time. And then we're using them as these interpretive lenses when we have this very modern science, including the work that we're doing in our lab.
But one of the stories that I really connected to, one of the pieces that I really connected to, and also we share something in common because I had grown up, not exactly in common, but I had grown up in the Catholic Church. And then I was almost a nun, and then I ended up breaking from the Catholic Church.
Oh,
and
wow.
Yes.
I would read that memoir if you haven't already written it.
Totally different direction. So I understand why you end up where you ended up. So I think one of the things that we used to learn about Augustine was that even as babies, we're sinful. That even I forget the section from Confessions, but he was saying that even when you're with the mother, but even when you're a child, you're still yearning for more milk or something like that. I don't remember it. But so I think on 248, you talked a little bit about, it really hit me when you said words of mercy rather than blame, of hope rather than despair, of evolution rather than perdition. And that was kind of how we would deal with this radical compassion you're kind of advocating for. Whereas we will not hear from a God and long to hear from each other. neither do I condemn you. Go and sin no more. And from what I remember, that's what Jesus said to the woman who was being stoned.
Yeah.
So can you talk a little bit about sort of involving, faith and religion in this book, kind of generally or specifically?
Yeah. So it's interesting to me that it resonated with you because you were raised Catholic. So many people that have reached out to me about the book have had some sort of early intense religious childhood that maybe they've moved away from or questioned or evolved
Mhm.
differently from. And it's made me realize how many of us are out there who have
Mm.
been raised very steeped in one religious tradition that we haven't necessarily carried totally intact into our current adult lives. So
Mm.
I was raised an evangelical Christian in the South, and so not necessarily reading Augustine, but reading Calvin, another figure in the Protestant church that was really kind of an extreme formulation of Augustine that I was taught that we are predestined. We're predestined to either be sinners or saints, that we're predestined for either heaven or hell. And it's interesting in retrospect to think that in my 20s, I thought I was moving away from my religious tradition and moving to science. And the science I moved into is all about genetics and what do we inherit and how does it shape our behavior. It's clearly still a preoccupation with what is it about ourselves that we're beginning life with that really shape how our life goes from there. Um, so the book is in many ways me wrestling with my own journey of I was taught to believe in heaven and hell and inherent sin, and I study what people inherit genetically influence their behavior. What do I think now? And it's made me realize how much of my thinking is still very Christian, but Christian in a way that emphasizes grace and compassion.
Okay, so yes, I mean, I was raised in an evangelical family as well, so we can all have that together. Um, now, the church might, in both the Catholic and evangelical church, might be very Calvinistic or Augustinian in the way that they think about sin, but Americans are a little bit more on the Pelagius side of things, particularly when it comes to genetic ideas. Like, and as you pointed out, like the idea of the gene has been around, what did you say, 75 years? And the Human Genome Project began in 1990. I remember when they said they were going to, okay, we're going to map it, the whole genome. And you point out that, like, for a lot of issues, Americans are willing to take the view that, like, what's natural cannot be called evil in Pelagius's view, like that you do inherit certain traits and you're not as morally responsible for them as you might have been thought to be at an earlier time. Could you talk about that a little bit?
Yes. So I think the example of Pelagian thinking that we're living through right now is how Americans' attitudes around body weight and appetite are shifting in the wake of the obvious effectiveness of GLP-1 agonist drugs like Ozempic. So we can see in research on people's attitudes that the more a person thinks that that body weight is biological or genetic or inherited, the less likely they are to think that body weight is a matter of willpower or that people are morally weak or that they're morally blameworthy in some way for having a larger body weight. And when people see that there's that, if we intervene with a biological mechanism, you can change someone's weight, you can change someone's appetite. People's attitudes tend to change such that they have less moral stigma around having a higher body weight. So
Which
I
is
think
not
we're
how it
living.
used to be, because gluttony was on that list of seven deadly sins, right?
Exactly. Gluttony is a circle of hell in Dante's Inferno. And we have, for many decades, there was good evidence that the type of drug that eventually became a GLP-1 agonist could be developed. And there was very little, ironically, appetite, I'm going to use that word, amongst pharmaceutical executives for pursuing that line of research because they thought, well, this couldn't be something that we could intervene in biologically because this is a matter of willpower. This is a lifestyle choice. And once it was clear that the biological mechanism was so effective, people's attitudes towards weight really shifted. We've seen similar shifts historically before. Autism spectrum disorders used to be blamed primarily on mothers. It was
Well, we
refrigerator
figured out that
mothers.
those are caused by vaccines, right? So we've solved that problem.
Well, I think that's a really interesting backlash is that now many people have rejected the evidence that autism is a highly heritable condition. It's primarily caused by genetics. They're blaming it against all scientific evidence on vaccines. And what does that do? That relocates the blame in the mother. So it's genetics or it's moms making bad choices is the backlash that we're seeing. And we've seen it with sexual orientation. There's really good research that narratives around born this way or sexual orientation being biological, innate, inherent, really drove changes in attitudes towards gay rights, particularly amongst people who were already politically liberal in the 1990s. So we have across multiple domains examples where genetic research or neuroscience research that locates behavior in the body somewhere as biological, has been really influential in reducing the moral stigma around those behaviors, reclassifying them as natural variation, not even a matter of moral concern necessarily. So even though Augustine won this debate within the Christian church, we still see this, again, this broadly Pelagian formulation of the relationship between biology and sinfulness for some things, but not everything. And I think that's an interesting, this debate that they were having in the Christian church. I think we still see evidence of this debate or this tension because our attitudes and our interpretations of genetics can differ depending on the specific behavior we're looking at.
And yet, while we might give people a pass for being genetically predisposed to obesity or autism or depression, we don't seem to feel the same way when it comes to crime, specifically violent crime. Well, your research suggests that there might be genetic factors that lead to aggressive behavior or other forms of criminality. Could you outline those factors and then read a section of the book to us?
Yeah. So if we're looking at this scientifically, either we're looking at it in terms of how much do family members resemble each other for a behavior, how much does something run in families, how much do children resemble their biological parents, even if they've been adopted away at birth and raised by different people, or if we're looking, like I just was describing earlier, at specific measured genes. Antisocial behavior and aggression is every bit as genetic as body weight, as autism, as other mental illnesses, as sexual orientation. So there's no clean distinction scientifically between these are the behaviors that are influenced by biology and these are the other ones that are not influenced by biology. Like we see the same strength of evidence for genetic influence on all of these things. But people's intuitions about how to interpret that really change as soon as there's an obvious victim or harm involved in a behavior. So if we're given evidence that sexual orientation is heritable, people tend to say, okay, well, then it's not a moral issue. Like this, there's no victim here. It's just natural variation. But you can't reclassify aggression as not a moral issue because there's an obvious victim involved. Or at least you can't do that very easily. And so what people tend to do is their intuitions about the relationship between how biological it is or how genetic it is and how much people are to blame for it or how much they should be punished for it shift from this more Pelagian interpretation to this more Augustinian narrative where inheriting something doesn't get you off the hook. It actually makes you even more sort of inherently damnable or blameworthy or punishable. There's a great study by the psychologist Susan Gelman and her colleagues where they give participants a bunch of hypotheticals about a sperm donor. They say, imagine you went to a sperm bank and you conceived a child. And then after you conceived the child, you learn various things about the sperm donor. What is the likelihood that the child conceived with that sperm would show these characteristics? And it's a way to get at people's intuitions about how inheritable something is without talking about scientific, concepts. And so you say, oh, if the sperm donor is tall, how likely is it that the child conceived with that sperm will be tall? If the sperm donor speaks French, how likely is it that the child conceived from that sperm is going to, speak French? And people are generally right. They're like, well, the child won't speak French, but it will be tall. And then people really vary. If you say, if the sperm donor committed murder, how likely is it that the child conceived of that sperm will also commit a violent crime? And some people say no, they think it's totally socially transmitted. Some people think it's just as inherited as height, and there's the whole variation. People who think that violence can be biologically transmitted, then when they're given the choice of how much should someone be punished for a crime, they actually say that person should be punished more for the crime. And that might have to do with they think they're more dangerous or less likely to be rehabilitated or less likely to change. But it's a really clear instance that thinking that something is inherited doesn't make us say, well, I guess it's okay that they're, murdered someone. That's no longer a moral issue. And it doesn't soften on average, our sense of how much that person should be punished. And I think as a scientist, that was kind of one of my on-ramps to this book is the science looks so similar across different domains in terms of how much the genetics matters, but our response to the science in the culture can swing really wildly from one direction to the other. So I think y'all wanted me to read a passage about one specific gene that can contribute. I will say this is a passage about a very rare genetic variant. So this is something that's very uncommon in the human population, but it's a good example of how could inheriting a different gene affect something as complicated as aggression and violence. Okay. What a child is inheriting when they are conceived is an entirely unique combination of 3 billion DNA letters, which are commonly abbreviated A, C, G, and T. A 3-letter sequence of DNA letters, what you might think of as a genetic word, is called a codon. When coding DNA is read by the cell, a molecule called messenger RNA carries copies of the DNA sequence to specialized organelles called ribosomes, which turn the DNA instructions into proteins. A 3-letter DNA codon corresponds to a particular amino acid, which is the building block of a protein. The MAOA gene, for instance, codes for an enzyme called monoamine oxidase type A, which eats molecules that the cell doesn't need anymore. Ordinarily, the MAOA enzyme breaks down the chemical messengers that neurons use to communicate with one another, messengers like serotonin or norepinephrine. Most psychiatric drugs, like Prozac or Ritalin, work by changing levels of these chemical messengers. But in the Brunner syndrome family, a single DNA letter in the MAOA gene has been changed to a T instead of a C. And this has changed the codon from CAG, coding for an amino acid glutamine, to the codon TAG, which means stop. Stop adding new amino acids, stop making the protein, stop regulating one's rage, stop developing the joint excellence of reason and character. The resulting MAOA enzyme is a stunted, deformed thing that cannot function normally. MAOA enzyme deficiency, in turn, leads to a buildup in the neurotransmitters that neurons use to communicate with each other, a suppression of rapid eye movement sleep, and a tendency towards explosive outbursts of anger, especially in response to fear or frustration. To inherit this mutated gene is to be prone to engage in arson, rape, assault, or even homicide. There is, at present, no cure.
Thank you very much. I had some flashbacks to my molecular biology class of college, which I think I failed miserably. I quit at the midterm, but I do remember some things.
Y'all picked the passage of the book that is probably the most scientifically dense paragraph.
It's true.
Yeah. If you're thinking about picking it up, there's not.
In the book, but
yeah,
I think
not
it's
so
cool
much
to think about the
bio
science. We don't get a lot of science on this show.
Oh, great! I like being people's token scientists.
But I mean, you do around that passage give us some very horrific examples of the actions committed by people who had that particular mutation. And I wanted you to talk a little bit about how this concept of genes predisposing people to criminal activity has begun to show up in the legal system. I mean, I was thinking, well, boy, if Law and Order was still on the air, we'd have an episode about, maybe there already is a Law and Order episode that you
Maybe
know,
there
in which
is.
somebody tries to make this defense. What is the scientific? You've talked about the social consensus about this,
Yeah.
but what is how is this applying in the legal world?
So it has been applied in the legal world, but there is no consensus about it. There have been a few cases. I write about one in the first chapter of my book of a man in Tennessee who attempted to murder his ex-wife and murdered his ex-wife's best friend. And in his trial, the defense offered evidence that he maybe had a different version of MAOA, not the very rare variant that we know definitely causes this impulsive aggression, but a different variant in the same gene. And he was convicted of a lesser crime. So the prosecution was seeking first-degree murder, premeditation, possibility of the death penalty. He was eventually found guilty, but of I think, second-degree murder. And interviews with the jury suggested that this idea of my genes made me do it, he had a bad gene, he couldn't be held responsible, was very influential to their reasoning. This case was in the early 2000s, and at the time, there was this expectation that maybe it was going to open the floodgates to genetic evidence being used in criminal trial. But in fact, it has not been widely adopted. And when it's been adopted, it has not been uniformly or even typically successful. So most of the time, genetic evidence, if it's entered at all, is entered at the mitigation part of a trial. So after they've said, yes, you've done it, like you're guilty of doing it, now we have to figure out how much we're going to punish you. And typically, it hasn't really seemed to make that much of a difference to judges or juries if you say that this person has an inherited family history or they have a particular pattern of genes. The Supreme Court of New Mexico has actually said, unless you can give us more convincing evidence that basically they couldn't have done otherwise, that we don't really want to hear this genetic information anymore. So I think that's interesting because we can contrast it with other risk factors for violence. So if a child has been maltreated, abused as a child, they are more likely to commit a violent crime in their adulthood. They're not fated. It's not deterministic. It's a risk factor that interacts with everything else. And it's very common in serious cases for there to be mitigation specialists that say, yes, they did it, but also their behavior might have been influenced for this thing that happened to them as a child. And that tends to be very humanizing. Your genes are also something that you got even before you were a child, the first moment of your childhood, and they also might increase your risk, but genetic information is not nearly as reliably mitigating or even used in comparison to these more environmental risk factors. Now, what's going to happen in future years as our genetic information gets better and better? I don't know. I think that the lesson of the last 25 years has been that genetics is full of surprises and that people's reactions to genetics is also really full of surprises. So I think it's going to be something that continues to evolve in the legal system.
So, in Current Affairs, Jill Levoy wrote a review of Original Sin that focuses on social causes of criminality. She argues that historical discrimination, civil war, segregation, and policing controversies combined with perennially low solve rates for violent crime are more important causes of crime and incarceration rates among Black men than genetics. How would you respond to that?
I think I would agree with her. So, when we're talking about a behavior like crime, I mean, crime isn't one thing. As a psychologist, I think of there's behavior, and then there's how is that behavior judged by society? And some things are classified as crime, but I'm really, as a psychologist, I'm interested in what are people doing? Mm-hmm. But all of those behaviors are incredibly complicated, and they're not caused by just one thing. And the causes, what are the most important causes? might really differ for people who are being raised in different environments with different risk factors and different times and places. So I'm a behavior geneticist by training. I'm writing a book about genetics because that's what I know about. And race is not genetic. The differences between black and white, those are social categories. Those aren't genetic categories. Again, all humans are 99% genetically the same, regardless of race. And most of the differences between us they're not bound by one racial category. They're not just only here in the people that we've put in the box white, or only found over here in the group of people that we've labeled as black. So the toolbox that I have as a behavior geneticist can understand how do people what are individual differences in response to an environment, but it can't really explain differences in racial disparities. So I think that the problem that she's pointing out in that review is such an important one. Like, why do certain people, Black men in particular, in our country, suffer from such a disproportionate burden of exposure to violence and also entanglement in this incredibly retributive, punitive criminal legal system? I think that's a really important issue, but it's not one that I can shed light on with the toolbox of genetics, because again, race isn't a genetic construct. It's not a genetic category.
So there are so many vulnerable personal stories in this narrative, including a bad LSD trip, divorce, and the complicated feelings you had about the birth of your own children. How difficult or liberating was it to write these sections compared to the scientific analysis?
Yeah. I wouldn't say it was difficult to write the personal stories. In some ways, those were the easiest to write because they kind of fell out of me. It sort of seems like I needed to put them on paper to make sense of them.
Mm.
One of the metaphors that I was working with when writing this book is thinking about a quilt. I'm a quilter as a hobbyist. And, quilting, you have this juxtaposition of lots of different fabrics, lots of different elements. You need to have negative space in there. But then it's the actual quilting, it's the actual stitching that makes it often feel cohesive and whole.
Mm-hmm.
And so the most difficult part of the book for me was, okay, I have these stories and I feel compelled to write about them for some reason. My subconscious is flagging them for me. And then doing the work of kind of following the thread of my own subconscious. Like, what is it about this story that seems to illustrate a broader point or a more abstract point, or to follow the scholarly argument that I'm trying to make here? And then how do I make the juxtaposition of that with the scientific content not feel like there's two different books here? How do I make it feel cohesive? So then I had to write about the science in a way that's different from my usual academic register and carry some of that personal voice through. And I think that was the most challenging part, which was, breaking up with writing like an academic. Right now, this is not the discussion section of like my normal peer-reviewed paper. How do I take something that I'm used to writing about in one register and stitching it together with the more personal stuff in a way that, hopefully feels more cohesive, more quilted together, and not just kind of pastiched in a way.
Yeah, you did so brilliantly. So,
oh, thank you for saying that.
For sure. I love this book so much. I thought it was fantastic. So,
the Times did use the term tapestry to describe the book, so they caught on to what you were trying to do there. Sorry, we have one last question here. It's going to be really easy. Okay, it's a piece of now we've got all this new information about how people's actions are actually influenced by genetics. You mentioned that I think it was your boyfriend calls your one of these papers your Minority Report paper, right?
Yeah,
At the very beginning of the book. So what happens when we start saying like, hey, if you have this gene, you're going to only be able to do these things? Or like, is what, in other words, what, that's one way we could use this information. What are we likely to be using this information for in the future? How does it change the way that we think about crime and punishment?
Yeah. So I don't think that we are ever going to get to this Minority Report pre-crime. I can predict with certainty that you're going to behave in this certain way. And there's two reasons for that. One is that genes don't do just one thing. They do lots of things in your body. And we see that even people who have the exact same genotype, identical twins, can have differing life course outcomes. They might have very similar temperaments. They might be very, tolerant of risk and really bold and, don't learn well from punishment. But that doesn't necessarily have to be violent crime. That could be being an entrepreneur. That could be being a creative. That could be being a leader. So
you have this one line from somebody who says, like, not all the psychopaths are in prison, some are in the boardroom.
In the boardroom. It's true, right? And so I think we see in humans, but we see in non-human species that any complex behavior can never be exactly projected from someone's genotype, especially when we're moving from like incredibly rare genetic disorders to sort of common genetic variation, which is what we study. The other thing is just what can we learn from knowing that these behaviors, even these behaviors that are so sensitive politically, that are so the object of such moral concern religiously, that can be so harmful to other people, just knowing that they are shaped by the genes that we inherit. And yes, you can take that in a very punitive Augustinian direction, that like people are born bad. I don't think that people are born bad or born good. I think that people are born complicated, and none of our behavior is reducible to one gene, and none of our identities are reducible to, an all good or an all bad judgment. When I started this book, I was, I think, subconsciously still really focused on this question of what do people deserve? Like, do people deserve to suffer? For what? How much? And was thinking that maybe if I spent time thinking about the genetics, it would help me answer that question. And now that I've written it and then rewritten it again, I think that the question of what do people deserve is a hopeless, unanswerable, bottomless black hole of a question. And it's not the right question to be asking. The question that we should be asking is, how do we want to treat each other moving forward? And I spend all day, I teach this stuff, I write about this stuff. And for me, thinking about genetics in relation to our most personal behaviors has increased my sense of awe at how are there humans? Like, this is amazing that this all ever comes together. And also empathy for how fragile all of us are, how close we are. Just one thing went awry, we would be different people. And if you go into a conversation about crime or punishment or retribution with a sense of awe at the dignity of human life and empathy for its fragility, I think it's really hard to maintain the retributiveness, the harshness that characterizes so much of American society. And that's if I want people to take anything away from the book, it is a little bit of that awe, a little bit of that empathy, and a little bit of questioning whether harshness has any redeeming value.
So Paige, thank you so much for being on the show. Listeners, be sure to pick up a copy of Original Sin on the Genetics of Vice, The Problem of Blame, and the Future of Forgiveness at your local independent bookstore.
Thank y'all for having me.